Hello, everyone, and welcome to the mini class. I'm Joy Lee, the International Training Engineer of the Supermap. Today is our first course of the series of mini class at the International Station of the Supermap Training Camp. And the Supermap GIS Training Camp, the International Station mini class is for people who are interested in GIS or GIS workers around the world. Why is called the mini class? So first, because of the time is 1 hour to 2 hours. And second, there will be some small exercise in class to let everybody experience the fun of the GIS. So there will be the total of 8 mini classes of 3D GIS technology. So students who have completed all 8 times of punching and passed each in-class quiz, and you will eventually obtain the certificate of completion issued by Supermap software company. So this is a QR code of our quiz. And there are 10 questions in this quiz. And each question is 10 points. It's finally passed with 8 points or more. So everyone has many chances to answer these questions, and we will get the highest result. And you could do it before our next class. Okay, so let's start our first class. Today, I'm going to introduce you our first course. It's focused on the new generation of 3D GIS technology and application, which helps you understand the most cutting-edge development of 3D GIS and its typical applications in various industries. Okay, so with the continuous development of various series, and such as the GIS technology, computer technology, and computer graphics, and virtual reality technology, the 3D GIS has gradually become one of the mainstream direction of GIS research. And it is also one of the most popular technical systems of the Supermap software, and its application popularity is increasing year by year. There are other technical systems, is big data GIS, AI GIS, distributed GIS, and cross-platform GIS. And we will introduce it to you one by one in the next series of courses. And this is the Supermap 3D GIS technology system. We have 4 parts of the technology system, respectively are the 2D and 3D integration model, and 2D and 3D integration, and multi-source 3D data integration, and 3D interaction and output. And this is a question in our quiz. The Supermap 3D GIS technology system has 4 parts of the technology system. And we also use these 4 parts to take everyone to explore the new generation of the 3D technology. First part, I'm going to introduce the 2D and 3D integration model. First, the data model is the basis of 2D and 3D integration technology. And data is also an abstract expression of material in the real world. So only data can perform the various technical operations, such as a 3D storage, calculation, and analysis. And then in the Supermap, according to the spatial distribution characteristics of the data, we re-synthesized them to 4 big categories. The data expressing objects in discrete space, and the data expressing a continuous surface, and the data expressing the continuous space, and the network expressing a link relationship between the objects. And let's take a look at this in detail. So the first step is that express the objects in the discrete space, mainly include 2D point, line, polygon, and 3D point, line, polygon, and the solid models that we often use. And the second tab is the network data expressing the link. Okay, the second tab is the network data expressing the link relation between the objects, and it's mainly used to express the connection relationships, such as the paths and path gallery pipelines, and so on. So the third and fourth tabs of data models are field model that represent the heterogeneous and continuous spatial phenomena, and the well-known the triangulated irregular network, which is a TIN, the TIN, and the grade. It's correspond to our oblique photography model, and it's beautiful with a photographic rendering effect, but it's essentially a surface model. And there is also a data model based on the TIN. So the grade is also the widely used. The most common of which is a expression of the 3D terrain, but they are not really 3D. It's 2.5D. So they have not yet completed the upgrade, and they need to be upgraded. As we express the geological ore body, and we can use the solid object model, because the ore body is relatively large. It can be expressed by the solid model. And then for the electromagnetic field, or the air property field, or the geological property field, what data model is used to express this continuous and heterogeneous 3D solid space. So TIN and the grade needs to be upgraded from the 2.5 dimensional to the 3-dimensional. And after the grade refers to a triangulated irregular network, that is a TIN. It is named the TIM. The tech is a tetrahedralized irregular mesh, and it refers to TIM. And TIM can represent the irregular division of a 3D continuous space, or the phenomenon. Let's take a look at the data model's evolution. We completed data model upgrading work 3D vector grade TIN to 3D solid object model and TIM for 2D and 3D model. So firstly is to upgrade 2D network model with the topological relations to the 3D network data model, and conveniently represents the urban road network and BIM pipeline. And secondly, the discrete data model from the points, lines, and polygons to the 3D point 3D solid model can be used to represent the objects such as the buildings. In addition, in order to represent the continuously distributed and the heterogeneous data in our daily life, such as the temperature and the sunshine distribution and the traditional TIN and the grid data are upgraded to TIM and the Voxel Grade. Okay, and let's look at this model in details. For the first is a 3D solid model. For example, we use a 3D solid model as the BIM in the urban design. And with the development of our data model, the antenna lobe and the fan beam can be visualized through the solid model, which can more accurately show the signal distribution in intensity in the 3D space, and provide them with the elevation, optimization, and network service. At the same time, the terrain can be clipped to build a 3D solid model, and then we can export it to the STL data format. And the Supermap at desktop also supports this format for export. In this way, the 3D printing equipment can print the output, the three-dimensional volume model. And this 3D printing application requires the support of the 3D solid model. So that is a result of the 3D printing results. When we do some spatial analysis, we can not only obtain the analysis, the line, and the polygon, this 3D analysis result, but also generate a 3D analysis result. Just like this analysis, we can find out, such as a shadow analysis, whether the generated shadows affect the sunlight of the nearby buildings, or the analysis of the skyline. If you want to build a new building, does this building affect the current skyline? And you can use this analysis results of the 3D solid for the further analysis. Okay, so now let's do a shadow volume analysis to get the feel of the 3D solid model. And whether the generated the shadow model affect the sunlight of the nearby buildings. And now let's open the Supermap at desktop. So I don't know, does everybody downloads the Supermap at desktop? And if you have any problem, you could contact me with my email. Or and let's open the Supermap at desktop. Okay, this is the index of the Supermap at desktop. Okay, and so first our exercise is to build a shadow volume analysis. And I have give you the data in the CBD dataset. Okay, and we will use the CBD dataset.smw. Okay, and maybe some people haven't downloaded the Supermap at desktop, and if you have some problem, and you could download after our class, and you could do it after our class. So if you have prepared our data and Supermap at desktop, and let's do our first exercise. Okay, let's import our CBD data size.smw, and we could click the File button and open the workspace. Open the File workspace and found all, and I will find my data in the CBD dataset, and click the CBD datasets.smw. Click the CBD datasets.smw. Okay, did everybody open this workspace? And I will check our chat box. Is the software free? Yeah, it has 3 months free lessons. What's the data structure used in Supermap? What's the data structure used? That is the next question. The data structure, you could see that it includes a workspace and data source, data site, and for the spatial data, it's in the data sites. It's stored in the data sites. So that is a really detailed knowledge, and we will have the class, we will have the course to explain it. Can we have the link to download? Yeah. 那样把那个 link 再发进去给我。Okay, thank you. Oh, screen still in beauty. Okay. Okay, if everybody has opened the workspace, and so let's do it. So first step is add this data to the new spherical scene. We could right click this data. Okay. Okay, could everybody have see my screen? Okay. And let's open the data for the CBD data site. For the CBD data site, and find the CBD datasets.smw. Find the CBD datasets.smw and open it. We could drag it to our desktop, or open it in the tab of the start. And open the CBD dataset workspace. Okay, so let's do our first step. add this data to the new spherical scene. Right-click this data and add it to the new spherical scene. Oh, okay. So we don't have Supermap app. Okay. I have sent the email to the registered people, and let me think. Okay. Let's look at this. I have uploaded to the Google Drive, so I will. Yeah. Yes, I have uploaded to the Google Drive from the data, and you could find this the data link. In this link, and it has our Supermap software. Yeah. And so let's start it. Add this 1, 2, 3, 4, 5. Add this 5 data to our spherical scene. We could right-click it, add it to the new spherical scene, and right-click data in the layer manager and zoom it to the layer. And we could see our scene in the map window. Right. Okay. Okay. Could everybody see my screen? Right-click this data, add it to the new spherical scene. Add it to the new spherical scene, and right-click the data of the layer manager. Right-click the data in the layer manager and zoom it to the layer, and we could see the scene in the map window. And then let's choose the building. Okay, and let's choose the building. We could click this select and pen select. We could select the building. Let's select this building and generate a volume model. Like use the 3D designer in the tab of the 3D designer, and there have the build shadow volume. There has a button of the build shadow volume. Okay, and click the sunlight source. Click this button, and it will appear that we selected objects. And let's select the time. We could select the null and click OK to generate the shadow volume. Click OK. Okay, it will create the solid model. We could see that is a solid model, and we could click this eyes and invisible all of the model data. We could see This is the volume that we have generated. Okay, and from this volume, and we could modify that whether the sunlight is affects the nearby building. Right, that is our first exercise. And if everybody has not follow me, and you could see our record of the video. Okay, and let's let's go on to the next step. Okay, this is our first exercise, build a shadow volume analysis. And then I'm going to introduce you the TIM model. The TIM model, its smallest unit is the irregular tetrahedron irregular mesh. In terms of the spatial structure, the TIM is composed of the multiple irregular tetrahedron with a topological connection and separation. It can represent the irregular division of the continuous 3D space. And the TIM can express the geological attribute fields like the porosity and the permeability and so on. So let's look at the application of the TIM model. In this video, we can see that use the TIM 3D field data as an entity to visually express the internal of the data in different ways, such as setting different cutting planes for the section display. And there is also an application that uses the TIM to obtain any profile of the model, and use the TIM model to represent the geological body, and use the layered coloring method to express the attribute information of the geological body, such as porosity and permeability and water saturation and liquidity and the strong acid distribution. This model can be applied to engineering projects such as the underground tunnel excavation and the subway construction, or the providing the technical parameters and the data support for this application, for this industry. And based on this, choose the appropriate construction plan and the construction tools. Next is a Voxel Grade. It can be obtained through the discrete 3D space point sets with the attributes or the interpolation of the TIM model. So it's a regular divisions of the 3D continuous space, such as the cubes and the regular hexagonal and the prisms, and has a simple structure. So that is also the question in our quiz. So pay attention to it. It's the question of our quiz. It is obtained by the upgrading raster data. This is the question in our quiz, that the raster data is upgraded to what model? It's upgraded to the Voxel model. So the grade is upgraded to the Voxel grade. And for the Voxel grade, it has two modes. The first one is attaches the voxel grade to the surface of the model to express the attribute field information. As shown in the picture on the left, the voxel grade can be used to express the coverage strength of the signal on the building, so as to simulate the optimization scene of the communication network and provide the reference of it. And the other is to load the voxel grade directly. Let's take a look at it. The first. So that is the first mode. In this building model, the 3D field with certain future values represented by the voxel grade on the surface. And in this way, voxelized results could be attached on the building models. So that is the second mode of the duration of sunshine can be expressed based on the voxel grade. And the distribution of sunshine can be seen more accurately in space. And the analysis result is expressed in a cube grade. And we could set the red color to the longer sunshine time and blue to the shorter sunshine time. And you can also dynamically filter the display according to the value of each grade to view the internal effect. And this is an example of application to the earthquakes. Based on the high precision seismic vectors sampling data, the seismic velocity structure model data. When we imported the data into the 3D GIS platform and interpolated it into a voxel grade model, and then published it to the Supermap Webgl client for the visualization. And through this platform, you can conveniently view the seismic wave speeds at the different depths under the ground. At the same time, according to the certain data filtering, users can dynamically display the 3D structure of different wave speed ranges. And you can find the outliners in the same underground depths to provide the reference for the study of the internal structure of the earthquake prediction. And next, the voxel grade to express the air pollution. This is also the question in our quiz. So if we want to express the air pollution, we could use the voxel grade. And since this voxel grade can set the transparency, and we can see the degree of the air pollution. In the it can also be filtered, and it can also be filtered and displayed based on the attribute values to express these areas with a more serious pollution. And the voxel grade can also be dynamically sectioned to view the effect of the internal section plane. So we could see the internal section plane. And the above is the data model. And then I'm going to introduce the 2D and 3D integrated GIS technology. And that the 2D and 3D integration includes storage integration and analysis integration and software integration. For the first part, the data storage integration. The 2D data has already been managed through the spatial database. So while many 3D data are still managed through files, Supermap stores 3D model data and 2D vectors and terrains and images in a fully unified database, which makes it very convenient to add the 3D model data to users' business attribute fields. For example, it can perform the complex SQL queries and statistical functions to facilitate data management and maintenance update. As a basic way to express the content of the map, symbols can directly express the geographical scenes and phenomena. Supermap GIS provides a two-dimensional and three-dimensional integrated symbol construction. In a 3D scene, 3D points, line, and field results are used for 2D vector data to make the features more intuitive and expressive. In the scene construction, we can load the 2D and 3D symbols into one scene to the web browser, or based on the 2D data with the 3D symbols to express the 3D visualization, just like the expression of the 2D data on the left and the expression of the 3D data on the right. And then let's do our second exercise, 2D and 3D integrated scene construction. So anybody should do this exercise, and you will upload the screenshot to the quiz in the last question. And then let's open the Supermap at desktop. Okay, so open the Supermap at desktop and close the one workspace. Close this workspace and open the workspace named 3D scene.smw. Open this 3D scene.smw. Let's click the file and open the file workspace and click this 3D scene. We could open the 3D scene.smw. Open this 3D scene.smw. Okay, and in this workspace, it has a 2D map and 3D scenes. And let's open this 2 map window to look at how it looks like. Let's open this 2D map and open this 3D scene. We can find this, that is the same data. And for the 3D scene, it's expressed by the 3D symbols. We could see this is a building, this too is a building. Okay, let me check the checkbox. Is there have some question? 3D needs. Okay. So does everybody open our data? And let's look at the difference of the 2D map and the 3D scene. So this is vector data that we often used. And this is a 3D scene. It's expressed by the 3D symbols, but it's also this 2D. It's a vector data. Okay, and now let's look at how to do this 3D scene. And let's just do a simple operation. And for this building or for the water, and we could do this. We will do this exercise in our next class and our third class. Okay, so let's look at. So first step, open the symbol dataset. Open this symbol dataset and find the tree. And find the tree and right-click it, add it to the current scene. Or you could just drag it on our scene. So we could see we have added to our scene, but we can't find it, right? In this time, we could set its altitude. In the tab of the style settings, there have the extension settings, and we could set the altitude mode set relative to ground. Set it relative to ground and give it the altitude to 4. Okay. We could see the tree is appeared to the 3D scene. This operations is just to modify its dynamically altitude. And we could click our middle button of the mouse, and we could see it is up to our ground. Okay, if we set it to 5 or 6, it will up to our ground. And then that is also the 3D, that is also the 2D points. So how to express it in the 3D symbols? And let's right-click the tree dataset in the layer manager. Right-click the tree and let's find the layer style. It has the layer style. Click this layer style. Click this layer style and find the 3D symbol on the left. Find the 3D symbol and find the tree in the Market Library 3D. And let's click the tree 01 and set its scale to 4. And we could take a look at this preview window. That is the tree, the symbol of the 3D symbol points tree. And we could click OK. So let's choose the tree 01 and modify its scale to 4. Modify its scale to 4. And click OK. So wait a moment. and it is a successful way to express to the 3D symbol. Because we use the 2D data to express the 3D tree symbol. Like we have lots of the 2D data, and if we discard it, and it will be the waste. So if we do some operation to make the 2D data upgrade to the 3D data, it will be a very well source of the 2D data. So that is the operation of the how to use the 2D points and express the 3D data, 3D model data. Okay, so if you have done it, you could take a screenshot of this scene. Includes your surface and your time, and you could upload to our quiz. And if you have not done this, you could do it after the class, because the deadline of our quiz is in the next week. It's before our next class. So the deadline of our quiz is before our next class. Okay, so could everybody have some question? Or okay, and I will do the next step. Okay, that is our second exercise, the 2D and 3D integrated scene construction. And that's also the question of our quiz. Okay, you could do it after our class and take a screenshot, upload to our quiz. Okay, and then I'm going to introduce you the integration of the analysis function. Supermap analysis function integration, on the one hand, the results of the 2D analysis can be displayed in a 3D scene. For example, by performing a 3D buffer analysis on the road, which is a 2D analysis to obtain a road buffer object. And using the 3D relation query, you can obtain the non-compliant buildings within a certain range of roads, such as the detection of accident lines in the urban planning. Okay, and on the other hand, the 3D space analysis is based on the 3D scene. For example, in this video, we building a mountain tunnel, use techniques such as section lofting to construct the Voxel hall. We could see that is our Voxel hall, and use a convex hull. Uses the convex hull to construct a tunnel body. Use a convex hull to construct the tunnel body and perform a bottom operation, which is an intersection between the tunnel body and the mountain to obtain a 3D solid. And then we could delete the body object at the same time to realize the process of digging and through the tunnel in the mountain model. The next one is the integration of our software. You may often have such a question, whether there is a special 3D software in the Supermap. product system? The answer is no, because each product of Supermap is well integrated with the 3D GIS technology. They all have their own 3D GIS models. Like for the Supermap server, mainly it is could publish and management of the 3D surveys. And for the Supermap portal, it provides the integration and visualization and sharing of 3D results. And for the Supermap Edge, it provides the 3D related edge computing and service agents. For the Supermap desktop, it mainly provides the 3D scene construction and the data processing and so on. And it also provides the 3D SDK and API for the desktop, web, and mobile. And they also have the question in our quiz. For the Cloud GIS server, Edge GIS server, and the Terminal GIS for mobile, for web, for components, for a desktop, and Supermap Online. All of this is our Supermap GIS product system. Okay, and then let's take a look at the integration technology of the multi-source data. With the rapid development of data collection technology, there are more and more different sources and types of spatial 3D data, like the oblique photography model or point cloud BAM and so on. So how to achieve this efficient integration of multi-source data and improve the efficiency of spatial data has become a major challenge. So Supermap integrates the emerging oblique photography model BAM and point cloud and the other 3D data with the traditional image, vector, terrain, and precision model. And the underground pipeline and other multi-source data improves the data utilization rate. At present, BAM is applied in the field of the design and construction, but it cannot be used alone in the operation management after the building is built. So GIS can help BAM throughout the building's lifecycle management. In the design stage, it can be extended from the building designing to the urban designing. In the construction stage, it can also be combined with the cameras and the various sensors to carry out construction supervision. In the operation and the maintenance stage, GIS can do a lot. For example, the properties management or the emergency pre-plans and so on. So multiple data with a different precision could be integrated in the same 3D scene. Like the low precision data can be created with the high precision data by the certain operation and the tool set, so that BAM and the oblique photogrammetry can be seamlessly integrated with other 3D data. For example, in the picture, the BAM model of the hydropower station is integrated with the 3D terrain data to provide the hydropower enterprise with the data. It's a support during the construction, operation, and the management stage. So we have the multiple source data and how to access this data and how to manage, integrate, and apply them. Based on the distributed technology, we have achieved the efficient the full process management capabilities for the 3D data from the data access, data processing, service publish, and the multi-terminal application. So, how to solve the unified management of the multi-source data? The open standard system and the open data format means that any 3D data provider and the 3D data receiver can support the docking. At the present, on the basis of the OGDC standard and the 3D data read and write access interface has been expanded, providing a unified entrance for many multi-source heterogeneous 3D data. So what kind of applications can be made based on the above 2D and 3D integration technology? And let me introduce the 3D interaction and applications. Based on these GIS platforms, and we can easily apply to the various terminals to realize a 3D display, query, and spatial analysis, like in the web browser or in the mobile. And it also can be combined with the VR, AR, and other new technologies. So first, I'm going to introduce you the Supermap Webgl to you. It is a zero-client technology. So in recent years, the demand of the request of the 3D web applications has increased. So Supermap Webgl is a 3D web pluginless. It means it's a no plugin client product. So it's don't have the plugin, and WebGL is a 3D it's a 3D web application development, and it is extended on the basis of the open source framework of the system, and it implements a series of the GIS characteristics functional interface, and it's a lightweight, convenient, and it's really easy to use. And it supports the so many web browser, and it could support the multiple terminal like the iOS and the Windows. So then, what kind of the abilities does the Supermap account for WebGL have? It has a highly realistic 3D scene, and it has a full function. It means all of the function in the desktop, the Supermap Webgl, it also can use. And then it supports the carrying capacity of the massive data. So for the 3D spatial effects, it provides the point and the spotlight and other custom light source. It also provides the 3D spatial effects such as the dynamic texture, like the sky, ocean, and the self illumination based on. So based on these spatial effects, we can make the city night scenes. We can make the night of the city scenes. That is the high performance portrait effects. It can also make such as particle effects to simulate the flames and the rain and the snow and the spray paint. So for this, Patrick, and we will do the exercise in the next class. So if you are interested in this particle, you want to know how to do it, you could listen our next class. And then he also supports the functions that GIS platform can do, such as a region clip, space analysis, or edit drawing, or visualization. That's also the question in our quiz. So, what functions does the Supermap Webgl can do? And it supports the TB level projects at the same time. That is the carrying capacity of the large scale, and including the TB level terrain and image. And the large scale vector, it includes 100 million pieces. So that is carrying capacity of the large scale scenarios. And it is not only on the browser side, web browser side, but also on the mobile side. Okay, so the next is the application of the VR. It can realize the real perception. We can use the handle to use the icon to the pick and the query. At the same time, it provides the browsing mode of the keyboard driving, and it's automatic walking and automatic running, and combined with the oblique photography model. Okay, and the BIM and other indoor and outdoor multiple source or pipeline source, it will let users feel a more realistic 3D immersive experience. And the next one is Supermap 3D GIS plus AR. And the virtual model is applied to the real world, and the real environment and the virtual objects are on the same picture of the space in the real time. So it will let you have the deeper understanding of the objective world. And then it's a Supermap 3D GIS plus AR. The standard table of the AR scenic spot integrates the 3D topography of the scenic spot tower routes and the scenic support information and the service facilities. In the mobile device, you can get an overview of the scenic area and understand the distribution of the scenic supports and watch the panoramic view of the scenic spots. It's very convenient for users to make the strategies before visiting, so know the details when the visiting and recollect after the visit. And we could see that it combines the gesture and zooming, rotating, and moving the center table of the scenic spot, which can not only overview the panorama, but also focus on the details to enhance the tower experience. And the Supermap GIS has newly researched the Supermaps Scene SDK for the game engines. The platform is provided is provided in the form of the components. And the Supermap Pro plugin is used to load and display GIS data on the game engines. And it connects the 3D data made by the GIS software to the Open S3M read-write development kit and support the scene output and multi-source data import and GIS analysis functions. Finally, it connects to the game engine like the UE or Unity in the form of the plugin. Like, for example, we could use the 3D data to simulate the sky and water, these spatial effects. And or simulate such a war effect to get through the cross-border integration of the 3D GIS and game engine. Okay, and next, there are some other applications in the aspect of the municipal planning, and it's realizing the management and inquiry of the parcel information and demolition management. In terms of the traffic planning and design, it could assist in the design of the expressways and high-speed rail lines. And there is a FAIR platform. So how to find when somewhere has a fire, how to find the nearest rescue route and simulate the emergency route and the water jets. And then that is the more representative the construction management project of the building of the Beijing subcenter. It can realize video monitoring and progress supervision and construction monitoring whether the rain will affect the construction progress and so on. So it's the TIM mainly use the BIM model to simulate the construction site environment and the construction progress, and the on-site monitoring video is associated to realize all-around supervision. And there is also the BIM of the Shanghai Center, which has a very large amount of the data. And the model data volume is 252 GB. And the number of the model components is 3.15 million. So it is a really large data. And this project that so the Shanghai Center is currently the tallest building in China. That is the application of the 3D GIS. And then the last is Qingdao Geological Information Aided Decision System. So Qingdao Research Institute of the Surveying and Mapping applies the above capabilities to the Qingdao geological information accurately and the decision-making system. So through the real-time excavation and the sectioning and other capabilities to view the structural distribution of the geological layers in the real time. So it provides the support for the underground engineering risk assessment. Okay, so today's class is finished, and there is our YouTube account. So for today's video, and we will upload it to our YouTube. So you could subscribe us for the Supermap GIS. And if you there have some course in our website, and there you guys could reach us here for our another social media. And then that is our quiz. So for our quiz, and I will introduce you our quiz again. So our quiz is it will be the 8th quiz and 8 punch-in in our series of the mini class. And if you completed this 8 times of punch-in and the quiz, you will obtain the certificate of the completion issued by the Supermap company. So this is in this quiz we have the 8 question. We have the 10 question, and each question is 10 points. Okay, so everyone has many chances to answer these questions, and we will get the highest result of your quiz. And if you have any question, and you could contact us. So could everybody have another questions? And this is the Q&A session. Okay, thank you so much. The quiz have the thank you. So let's look at this. Thank you, everybody. And thank you. Thank you so much. And if you guys is interested in our mini class, and you could come for our 8 class. And we will have the 8 class, and you could come here to experience the fun of the GIS. Thank you. Yes, sure. the dates of the next classes. The date of the next classes, we will support it. We will send it to our Facebook, and so you could find it in our Facebook. And let me find this date. Look at this. So there is our a simple date. It's our simple date. So our next class is in the April 6th. It's in the April 6th. It's also from 3 p.m. to 5 p.m. It's the area is a UTC 8. And our topic of our second class is a basic knowledge of the 3D data type and scene. So if you are interested to our next 3D mini class, and you could follow us on Facebook and pay attention to it. We will put it on our Facebook. Okay, so our TA and me will ask you the questions, and so today our class is finished, and we will keep to ask your questions in the chat box, and will thank you so much. And okay, I will finish my video and close and mute